Alright, welcome back. So let's look at the second part of grinding processes. So when I say grinding processes, there are several methods of grinding. So you have the cylindrical grinding, you have the internal grinding, you have the surface grinding. Cylindrical grinding is used to machine cylindrical, tapered and formed parts. Okay, so what do I mean by cylindrical grinding? Yeah, cylindrical grinding is when the shape of your product is cylindrical in shape. Okay, cylindrical, cylinder. I'm sure you know what a cylinder is. Yeah, cylinder. This is a cylindrical shape. So when your product is in a cylindrical shape, you need to use a cylindrical grinding because the grinding wheel is designed in such a way. Okay, secondly, you have internal grinding. Internal grinding is when you need to grind the inner surface of your cylindrical part. So still, we are sticking on to cylindrical part. But now your cylindrical part has an inner surface because your cylindrical part is a hollow part. So when your cylindrical part is a hollow part, okay, when your cylindrical part is a hollow part, you'll end up using cylindrical grinding in specifically internal grinding. And number 3, surface grinding. Surface grinding is meant for flat surfaces of object. It can be any flat surfaces as long as the permukaan is permukaan rata, yeah, flat surface. So whenever your object is flat surface, you may want to use a surface grinder. So if you had observed, yeah, during your manufacturing processes lab, there was a surface grinder present in the manufacturing lab, and some of you would have used it especially to level up the sharp edges that were present in your final mini project workpiece. Yeah, so surface grinding is to remove or to smoothen sharp edges or to smoothen rough surfaces of a flat object. Okay, so according to the method supporting the work, let's look at the first one, cylindrical grinding. Under cylindrical grinding, there is center grinding and centerless grinding. What is center grinding? Yeah, center grinding. Okay, so this is a typical grinding wheel that you see here. Okay, this is a grinding wheel, and this is we call this, if you look at it closely, yeah, this is the surface, that like the surface I'm pointing right now. This is the surface that is going to perform the grinding operation, and this surface has, we call it mesh. It comes with a mesh size, meaning that the mesh will determine the roughness of the grinding process. So your mesh size will vary between 120, 240 mesh size, 600, 800 and 1200 mesh size. So as it goes down the gradient, 120 and 240 would be considered rough grinding, and then you have 600, 800 and 1200 which will be considered fine grinding. So like I had mentioned to you in the previous video, your object needs to undergo rough grinding first, and then it undergoes fine grinding. So you need to change your grinding wheel according to the type of operation that you intend to perform. Is that clear? I'm sure, I hope it's clear. Okay, so now going back to the topic, yeah, so I mentioned to you earlier, cylindrical grinding will involve center grinding and centerless grinding. So what is center grinding? Center grinding is the traditional or classic way of grinding where you have your workpiece clamped. Okay, it's being held at a chuck. We call this a chuck, the way I'm pointing right now. Okay, we call this a chuck, and your workpiece is actually clamped to make sure that it's held in position, and you have a supply of coolant. You see the free flow of coolant, yeah, so that your workpiece will not get heated up. Okay, and you are going, and the if you see there's an orange object over here. That orange object over here is your grinding wheel. Yeah, it comes with the right or the type of grid sizes. So if you see, the width of your grinding wheel is probably 10 mm, 20 mm. Okay, so you have a limited size. So for that particular reason, if you look at the length of your workpiece, it's super long. Yeah, your workpiece may be 8 centimeters long. So you cannot grind at one go. Therefore, you must make sure that your workpiece rotates in its axis, and at the same time, your workpiece needs to move back and forth to grind the entire surface. Yeah. So at one go you may only be able to grind 10 mm, right? So once it has grinded the 10 mm, the workpiece needs to go back and forth so that you can grind the entire surface or length of that workpiece. Okay, so it is a traditional way where you need to clamp the workpiece. What is the disadvantage of this technique? Yeah, it's been used for a very, very long time in the manufacturing industry. However, just like any processes, when it has an advantage, it comes with disadvantages. The main disadvantages of this process is you will find that if you have not clamped your object or your product properly, what will happen? There will be vibration of the product. So when the product vibrates, what's going to happen? You will start to have deep scratches on your surface of the product. So when there's deep scratches, your product will be a reject. Yeah, you do not want that to happen. And the setup time is very long because you need to go and clamp, adjust, and then when you adjust, if your adjustment is not right, you need to reclamp it again, so on and so forth. So the setup time involved is going to be long. So that's when people have second thoughts when they need to use center grinding. What's your other option? Okay, your other option is centerless grinding. So if you see here, this is a typical centerless grinding. What is centerless grinding? Do you see your workpiece being clamped? No. So in centerless grinding, your workpiece will not be clamped. Instead, you have your workpiece sitting or resting on a work rest. Then you have your regulating wheel and you have your grinding wheel. So you find that all the three wheels will rotate in the same direction. Grinding wheel clockwise, workpiece clockwise, regulating wheel clockwise. So when all the three wheels are rotating in the same axis, you find that what is the function of regulating wheel here? Regulating wheel will push the workpiece towards the grinding wheel. Grinding wheel will grind the surface of the workpiece, and since it's on a work rest, and if you look at the physical appearance of this grinding wheel, there is a grinding wheel slide here. Do you see here that there's a small button labeled as grinding wheel slide? So this is going to allow your grinding wheel to move back and forth and grind the entire surface of your object. Okay, so you'll have your entire surface of the object grinded. So your workpiece is going to rotate in its axis and be static on the work rest. What moves instead? The grinding wheel and regulating wheel is going to move back and forth so that the entire length of your workpiece is grinded. Is that clear? So as a manufacturer, which type of process would you select? Yeah, I'm sure you'll want to select a regulating, a centerless grinding because of its ease of use. There is no setup time, okay, and it's a much user-friendly grinding process. But again, as like I mentioned to you, all positives comes with some negative. So what's the disadvantage that is present here? What is the disadvantage that is present here? Number one, your object cannot have a flat surface, meaning your cylindrical object should not have a flat surface. Your cylindrical object should have a cylindrical surface. If it is a semi-cylindrical object, meaning that if it's a semi-cylindrical workpiece, something like this, yeah, you cannot grind it because there's a flat surface present. So you cannot use centerless grinding. And number two, if your object has multiple dimensions, meaning that is multiple diameters present in the object. Okay, it has multiple diameters present in that object. You cannot use centerless grinding. Keep in mind, you cannot use centerless grinding. So this ends this lecture for today. Let's continue in the next lecture with the surface and internal grinding. Thank you.